So let me give another example, okay? So as you can see here, this is first order nonlinear differential equation, okay? And also keep that in mind. At the end of this problem, I gave you y0 equal to 1, which is initial condition, which means you are not supposed to put your right-hand side as equal to 0, no, as equal to c, but you have to find the constant c with your like initial condition, okay? And also, when you start this one, some of you say like, hey, JD, that form is not the general form of the exact. I understand. Look at that. There is dx, but simply divide by dx on both sides, then you can easily find that's exact same with the form that I gave you in the theory and previous example, okay? Right? Then you can easily find this is m, and the coefficient of dy dx is n, okay? Then what was first step? You have to really check it is exact solution or not, exact differential equation or not, right? So you have to check my is equal to nx, okay? What is my my? My is e to the power x prime is not e to the power x, but it is equal to 0 because e to the power x is constant for this differentiation, okay? And y prime is 1. And what about nx? 2 prime 0, and x prime is 1, and y times e to the x prime, no, it's not the product term, but it is equal to 0 because like we consider all the like function of y as the constant, right? That's it. Yes. So check. Then I can say it is the exact differential equation. Now, we have to find psi x comma y. And as I said, you can start from m or n, either way, okay? So you can try both of them, okay? So for the practice, let me try to use m, okay? But keep that in mind. Your m is equal to psi x, which means we're going to take the integral with respect to x, okay? So your psi xy, which is my target function, is equal to integral m dx, which is integral, okay, e to the x plus y dx, okay? So that is e to the x and plus xy. And don't forget, we must have function of y. This is my target function. Is that okay? And then we have to find f of y. For that purpose, it's time to use n. Your n is psi y, okay? Then let me take the derivative with respect to y. And e to the x prime equals 0. And xy prime is x. And df, it might be better to write as ODE, must be equal to your n. What is my n, by the way? There we go. 2 plus x plus 2 plus x plus y e to the y. Look at your left and right hand side, okay? Both of them has the x term, it is gone. But like, then we can say your df dy is equal to the remaining term, 2 plus y e to the y. Is that okay? Then, as you know, f of y is equal to integral 2 plus y e to the y dy, right? So, well, there are two functions, right? 2 and y times e to the y. Like integral 2 is easy, right? So it is 2y and integral. Let me separate, okay? Because that is easy, okay? And for this one, definitely you have to do the integrating by part, right? So let me like use the u and v notation, okay? My u is y and dv is e to the y dy, and my du is dy and v is e to the y. That's it, okay? So I'm talking about this part, okay? Is equal to uv minus dv, v du integral e to the y dy, which is y e to the y minus e to the y, okay? There is constant, but like keep that in mind. That constant will be added later. That's why like for now, it is okay, okay? So let me keep writing on the bottom. Even we don't have enough space, we can do it. F of y is equal to 2y plus y e to the y minus e to the y. We are not done yet. We have to plug in back into my psi function, okay? Therefore, psi x comma y is equal to, do I have more space? Oh, so, okay. X comma y is equal to e to the x plus xy, e to the x plus xy, and f of y, which is 2y, y e to the y minus e to the y. Therefore, my solution is e to the x plus xy plus 2x plus y e to the y minus e to the y is equal to c, right? But we are not done yet. This is the initial value problem. So which means, look at that. At the beginning, I said my y0 equal to 1, right? Plug in x equals 0 and y equal 1, then you can decide your constant c, okay? X equals 0 and y1. Even we don't have enough space, but let me keep writing, okay? Since f of 0 equal to 1, e to the power 0 plus 0 times 1 plus 2 times 1 plus 1 times e to the 1 minus e to the 1 must be equal to c. What is that? E is gone at the end. E to the power 0 equals 1. 1 plus 2 is 3. So therefore, my c is 3. And therefore, my final solution is e to the power x plus xy plus 2y plus y e to the y minus e to the y is equal to 3. That is the final answer.